Hello, everyone. Today, I'm going to guide you through the step-by-step process of building your very own DIY pager using Arduino. This project is perfect for anyone curious about wireless communication and electronics, and it's a fun way to dive deeper into the world of Arduino programming and hardware setup. Let's not waste any time and get started. First, let's talk about the materials you'll need. For this project, you'll be using an Arduino board, whether it's an Uno, Nano, or any compatible variant. The core of the communication system will be a radio frequency module like the NRF24L01, which allows wireless data transfer between two devices. Along with that, you'll need basic components such as resistors, capacitors, LEDs to act as visual indicators for received messages, push buttons for sending signals, and a power source like a battery pack or USB adapter to run your Arduino. Of course, you'll also need some tools, including a soldering iron, jumper wires, and a breadboard to prototype the circuit. Now, moving on to the hardware setup. Start by connecting the NRF24L01 radio module to the Arduino. This module communicates via SPI, so you'll need to connect the GND pin of the module to the Arduino's GND and the VCC pin to the Arduino's 3.3 volts. Then, connect the CE pin, CSN pin, SCK pin, MUSI pin, and MISO pin to the corresponding pins on your Arduino. The exact pin configuration may vary depending on the Arduino model you're using, so be sure to check the documentation. Once the radio module is connected, it's time to wire up the buttons and LEDs. The buttons will serve as input devices for sending messages, while the LEDs will act as indicators when a message is received. Connect the buttons to the digital pins of the Arduino, and ensure that the LEDs are wired with resistors to prevent them from burning out. With the hardware set up, it's time to move on to the programming. Open the Arduino IDE on your computer and connect your Arduino board via a USB cable. For this project, we'll be using the RF24 library to handle communication between the NRF24L01 modules. To install the library, simply go to Sketch > Library > Manage Libraries, and search for RF24. Install it and include it at the beginning of your code. In the program, define the communication channel and address for sending and receiving messages. One Arduino will act as the transmitter, while the other will act as the receiver. When you press a button on the transmitter, a signal will be sent through the radio module to the receiver, where the LED will light up, indicating that a message has been received. You can even add more complexity to the code by programming different buttons to send different types of messages or integrate an LCD to display text information. Once you've written the code, it's time to upload it to the Arduino. Simply click on the Upload button in the Arduino IDE. If you're using an external programmer, connect it to the ICSP pins on the Arduino and upload the code through the IDE by selecting the correct programmer. After successfully uploading the code, disconnect the Arduino from your computer and power it up using an external source like a battery or a power adapter. At this point, your DIY pager is fully functional. When you press a button on the transmitter, it sends a wireless signal to the receiver, which lights up the LED to confirm the message was received. You can further enhance this project by making the pager portable. using a smaller Arduino Nano board, or even incorporating an LCD to display text messages or alerts. You can also design a custom enclosure to give your project a more polished and professional look. If you're looking for more advanced features, you could integrate this project with other modules, such as GSM or GPS modules, to make your pager even more functional. For instance, adding a GPS module would allow the pager to send location-based messages, opening up even more possibilities for customization. That's it for this project. I hope you found this tutorial useful and that it inspires you to dive deeper into the world of DIY electronics. Don't forget to like this video if you enjoyed it, and be sure to subscribe to my YouTube channel for more exciting projects like this. Also, make sure to follow me on LinkedIn, where I regularly post updates about my latest builds and technical content. Thanks for watching, and I can't wait to see you in the next project.